Fractals are patterns formed from what are known as chaotic equations. They exhibit self-similar patterns of complexity regardless of magnification, and if divided into parts, produce a nearly identical reduced-size copy of the whole. With fractals, infinite complexity is formed with relatively simple equations. By iterating or repeating these equations many times, random outputs create amazing patterns that are unique yet recognizable. Most fractals in nature do not keep repeating their patterns forever. The repetition eventually breaks down in natural patterns and they cease to be fractals. Fractals are everywhere in nature. We begin our exploration of natural fractals with the universe in general. This is M51, also known as the Whirlpool Galaxy. This image from Hubble has been color enhanced based on the type of light wave frequencies captured, but it is an epic example of a spiral fractal. On the left is a subregion of the Mandelbrot set compared to another galaxy, the Grand Spiral Galaxy, on the right. In 2015, researchers conducted an extensive analysis of images received from the Cassini spacecraft and confirmed that the edges of Saturn's rings exhibit fractal properties. Recent research conducted at MIT based on computer modeling demonstrated that turbulence of objects entering a black hole forms a fractal disruption pattern, very similar to other natural liquid flows, such as when cream is poured into coffee. The cracks in the Vastitas Borealis crater on Mars were formed by sediment repeatedly freezing and thawing. Notice how the large crackling pattern repeats though the scale gets smaller toward the center, which is in the upper right corner of this image. Without a known context of measurement, the scale of this image is indeterminate, another feature of particular fractals. This is the surface of Mercury showing impact craters. Next, let's look at some fractals closer to home. Waves are some of the most common fractal patterns, both in art and in nature. In fact, fractal equations are used by CGI animators to produce realistic-looking water objects for movies and video games. Another common fractal pattern is that of a dendriform, or tree-like branching pattern, shown here on beach sand, created by water as it pulled away. The overall ledge or shelf shape of this coral colony is repeated by the many small shelves that form the whole. This soft coral is commonly known as tree coral. The branches are miniature versions of the main stalk, and their smaller branches are smaller replicas still, a perfect example of a dendriform fractal. Other living creatures display fractal patterns. Again, here is a fractal digital artwork based on Mandelbrot's equation and compared to an octopus's tentacles. This sea urchin skeleton is an example of a symmetrical fractal. Most of us are familiar with the fractal nature of seashells. The pattern remains constant regardless of the scale. Here it forms the spiked spired shape. Though the spiraling is a constant, this shell exhibits a slightly different fractal expression. Here is another digital fractal image, and while it demonstrates other special mathematical characteristics, the chambered nautilus is also a natural fractal. The geography cone actually develops pigmentation that displays the very familiar fractal pattern of the Sierpinski triangle or gasket.
Landform fractals can be identified in most types of terrain. These slides will focus on familiar landforms of the Pacific Northwest. This artistic representation of the Columbia Gorge is a perfect example of fractal patterns in landforms. Like most naturally occurring fractals, these shapes have grown through the passing of time. I'd like to draw your attention to the deep crevices that make up the terrain. If you look closely, you will also see that these crevices repeat infinitely as they grow smaller and smaller. Fractal equations are used by software programmers to create mountainous terrain for flight simulator programs. Prior to the discovery of fractal geometry, these types of learning tools were not possible. In this picture of the Rocky Mountain Range, we can see the interesting way the shape of the mountains is reflected in the terrain changes at different altitudes. This image, captured by a passenger on Delta Flight 232 over the Cascade Mountain Range, shows an interesting perspective. In this image, it's easy to see how the ripples in the landforms are similar to the patterns found in turbulent water or waves, as mentioned earlier. This beautiful image of the painted hills is not just stunning, but yet again is an example of fractals in the world around us. The color rings are similar to those we found in our universe, and the shape of the hills themselves is similar also to some ocean-going fractals. This is a picture of Mount Hood. Note the large ridges that go up the sides of the mountain actually form the shape of the mountain itself. Now note again that the ridges on those ridges also form the shape of Mount Hood, and on those ridges are smaller ridges still. This image of Fairy Falls in the Columbia River Gorge shows how waterfalls also can represent fractal patterns. The way the rocks jut out of the mountains cause the water to flow in patterns which repeat. The overall shape of the waterfall is repeated infinite times in the smaller waterfalls within it. Plant fractals are beautiful, and we are surrounded by countless examples. Again, the following slides will focus on plant species native to the Pacific Northwest. This is an image of the Mandelbrot set, named after the man who discovered fractals. It can be compared against nature in so many ways. Take this fern, for example. Its curls are very similar to the shape of the curls in the Mandelbrot set. And this broad-leaved lupine, its stalks are quite similar to the connectors between the different pieces of the Mandelbrot set. This aerial view of evergreens with new growth shows an amazing clustering fractal pattern. The new growth, seen in bright green, makes this pattern very easy to discern. This is an artistic representation of a fractal equation made to look like an evergreen. Notice the similarities to both the previous evergreen and the following flower. Queen Anne's lace is a native plant to the Northwest, actually throughout the entire continental U.S., and is a perfect example of a fractal. Notice the overall shape of the flower is repeated in the smaller clusters, and the tiny flowers repeat the shape within those clusters. This concludes our presentation on fractals in nature. We hope you've enjoyed the slide and that the information provided here will open your eyes to the world of fractals around you.